Hey guys, nice to meet you. I hope this video finds you in good health and in good condition. My name is Raymond and I'm a tutor for AthenaStudies. And today I want to help you a little bit with your new subject that you got for the course RMS, namely significance tests with proportions. And I wanted to give you a very practical example of how we can use significance tests with proportions with, for example, the presidential elections that will take place this Tuesday. And how can we use significance tests to decide who's going to win this Tuesday? So what I want to do, I want to go through a very practical example, a very typical exercise that you could expect from significance tests with proportions. I want to take you through the exercise. How would you do it? What are the different steps and why am I taking the different steps? And I won't go too much into all the theoretical details, since all the theoretical details are probably already explained very well by your professor in the lectures. So this is the case study that we're going to do. So in the United States, the presidential elections are coming up and the battle is on between Donald J. Trump and Joe Biden. Either Trump or Biden wins the presidential campaign when they have a majority of the presidential electors. In the weeks prior to the elections, regular samples are taken in every state to find out who's currently leading the polls. In the state Florida, which is currently a very important swing state, a survey has been given to a simple random sample of 102 participants in which they have answered the question, will you go and vote for Donald Trump? In this particular sample, 53 out of 102 people answered with yes. And the question we have is this good reason to believe that the outcome of this survey is bigger than the required population proportion? P0 is 0.5, because of course you need some majority of the votes in the population of Florida. All right, so we're going to do a significance test with the proportions. And that means that first we have to set up our hypotheses. And how would you set up your hypothesis in this case? Well, your hypothesis always consists of a null hypothesis and of an alternative hypothesis. In the null hypothesis, we do a certain inference about the population. So we have a certain parameter from the population, which in this case is the population proportion P0. And we're trying to draw conclusions about a population parameter based on the sample that we have. So in this case, we're trying to make a connection between the sample that we have. So let's say for the null hypothesis that our sample statistic P is actually equal to the population parameter P0. In the null hypothesis, we always write something down like the mean is 0, or there is no difference, or there is no effect. And the alternative hypothesis is always that there is a certain effect, that we can draw conclusions based on the sample. And in this case, we need to watch for some words that signal what the alternative hypothesis is. And in this case, we can find it here, because we are asked, is this good reason to believe that the outcome of this survey is bigger than the required population proportion? So our alternative hypothesis is that actually the outcome, the proportion from our sample, is bigger than the population parameter P0 is 0.5. If it would not say that the outcome is bigger, but it is not equal to or different from, then we would have written down this is not equal to. And that means that we are doing a two-sided test. And this is a one-sided test. Let me erase this quickly. All right, so this is our first step that we're taking. Let's draw it first into the sampling distribution. So I've already drawn a normal distribution here, and we're going to use this normal distribution to draw in our sampling distribution. And what is that sampling distribution? Well, of course, in the sampling distribution, we have a mean And the mean in this case is P0 is 0.5. Because imagine that the population parameter is truly 0.5, and we're going to take a lot of samples in the population of Florida. All these data points, because we're talking about a sampling distribution, all these data points that are in this normal distribution are outcomes from another survey. So this data point is the outcome from a survey with 102 participants. This outcome in the normal distribution is an outcome from a survey with 102 participants. All the outcomes in this normal distribution are outcomes from an independent survey of 102 people. All right, that is very important, and that's why we call it the sampling distribution, because it's the distribution of the samples. So this is the mean, because we are assuming that our null hypothesis is true and that the population proportion is actually 0.5. All right, and then we have, of course, a standard deviation in this normal distribution. And the standard deviation in a sampling distribution about proportions is called the standard error. We call it the standard error when we are working with a sampling distribution. And the formula for it is P0 times 1 minus P0 divided by n. And that whole thing, now I realize that I've left too little space for me to write down a square sign, but the whole thing is squared. And this is the standard deviation from the sampling distribution. All right. And what we need to do now is find out where the true value or where the outcome of our sample lies. And to determine where the outcome of our sample lies inside of this sampling distribution, we need to find out first what the proportion statistic is from our sample. And the proportion statistic is the amount of successes, so the amount of successes, which in our case, let's go back to the example, was 53 out of 102 people said yes. And whether or not you think 53 people voted yes for voting for Donald Trump is a success is up to you. But in statistics, we would call a yes a success. So this is our proportion statistic. And I've taken the liberty to already calculate it for you. And it is 0.5196. So if I would draw this outcome inside of this sampling distribution, because this is the outcome of one of the samples out of the sampling distribution, it would fall to the right here, because this is 0.5, it would fall to the right, somewhere around here, I don't know exactly, but let's just draw it in. This is where it falls in my sampling distribution. So 5196. All right, and now I need to find out what the z-score is of this value, because if I know the z-score, I can calculate the probability that I find this value. All right, so once again, we need to calculate the z-score, and the z-score is always the difference between the two values, within this, which in this case is p minus p0, divided by the standard error. And we just found out what the standard error is for the sampling distribution. It is the square root of p0 times 1 minus p0 divided by the number of participants inside our sample. This is a whole subject on itself, the standard error, and why the number of participants determines the standard deviation. And I will make another video about how that works, because it's really important that you thoroughly understand why we are using this formula. All right, so let's fill in all the values that we have. We fill in the p, which was 0.5196. And we divide it by the square root of P0, which was 0.5 times 1 minus 0.5, which is also 0.5, divided by n, the number of participants, which was 102. And out of this formula, we calculate the z value. So we calculate how many standard deviations this outcome, our p, of 0.5196 is away from our mean 0.5. So what is the z value? In this case, it is 0.396. So apparently this p-value of 0.5196 is 0.396 standard deviations away from the mean 0.5. All right, very well. What is the next step? Now we need to look at our hypotheses, and we set up the hypothesis, the alternative hypothesis, that p is bigger than p0, our population parameter. And that means we're doing a one-sided, where did my mouse go? Oh, it's here. We're doing a one-sided test. So I need to find out what the probability is that I find a value that is higher than 0.5196. And that means we're trying to calculate this area to the right of the p-value. So we're trying to find out what the probability is that I find a z value that is higher than 0.396. By the way, for those of you interested, I wrote down this equal than or bigger sign. You can also use just the bigger than sign. It doesn't matter because we're working with a continuum. And think for yourself what we would need to calculate this, this value. Because for this value, we need to use the z-table. The z-table gives us the left-sided probabilities of my z, while I'm actually trying to find the right-sided probability. So I'm trying to find the area to the right. So we need to use a little formula. We need to use the 1 minus p z value smaller than or equal to 0.396. Because remember that the total area underneath the normal curve, underneath the standard normal curve, is always 1. It's always equal to 1. And we're now trying to calculate this area to the right of my z value. So that means I need to do 1, the whole area of the normal curve, minus the area to the left of my z value. All right, so now let's find the z value. So I found a z value of 0.396, and in this table I can only find values of z up to 2 decimals. So I need to round this to 2 decimals, which is 0.40. So let's look it up. I need to look here. Z is 0.4, and my second decimal is 0. So I find this value here, 0.6554. All right. So this is 1 minus 0.6554. And that gives me a probability of, and I need to look this up, because my calculations out of my head are a bit rusty to admit. So this means that there, with this sample, there is around 44.5% chance that I find this value of p, while actually the population proportion is 0.5. So if I'm going to do this survey a lot of times, like a million times or an infinite amount of times, 34.5% of the time I will find a proportion. I will find a proportion that is at least 0.5196. So we now find that there is a 34.5% chance that I find this value. And when we're working with significance tests, we're always working with a significance level. And the significance level, we denote it by alpha. And the significance level tells you something about how sure do I want to be about the outcome of the sample. So if I find, for example, that I find this very special value, maybe something that lies here on the sampling distribution, only 5% of the time, then I say that case is so special, it's so rare that it happens, that I say, well, then probably the population proportion is maybe not 0.5, but it is actually bigger than 0.5, because the chance that I find this sample with maybe a p of, I don't know, 0.7 or something, that I find that value, well, actually the population proportion is 0.5, the chance is really small. And this tells you, the significance level tells you how sure you need to be. And in this case, we found a p-value of 0.3446, which is a lot bigger than our significance level, so we cannot be sure enough that the population parameter is not actually 0.5. So in this case, because our p-value is bigger than our significance level, we assume the null hypothesis is true, or we cannot say with enough confidence that it is not true, actually. All right. This is what I wanted to give you guys. I hope you understand a bit more about using significance test with proportions. In this case, as a conclusion, we can conclude based on the evidence that there was not strong enough evidence to believe that Trump truly has a majority of the voters in Florida. And we write it down like this. So thank you very much for watching this video. I hope you learned a lot from this video. Because we're really happy with all you guys, I provided you with a little discount code for our exam trainings, which will give you an 8% discount for our exam trainings. So once again, thank you very much and hope you have a lovely day.